Hi, today we'll start with the fifth module of this course. Okay, it contains Fourier integrals, Fourier transforms, and their simple problems are there. It's a very short module. The only type of questions which will be coming from this section is you have to expand a function as a Fourier integral, as a Fourier sine integral, cosine integral, or you have to find the Fourier transform. Okay, so these are the basic problems which will be coming from this section. Okay, the application oriented problems, like in the case of Laplace transforms, will not be asked from this section. So basically you have to study some definitions and also how to apply those definitions to evaluate the problems for the session. Okay, so what do you mean by Fourier integrals? Okay, so Fourier integrals is actually the extension of the Fourier series which you have studied in your last semester. Okay, so in the Fourier series, if you have studied, you know that Fourier series in Fourier, when you are asked to expand a function's Fourier series, you will write a formula like this: f of x is equal to a naught by 2 plus sigma n is equal to 1 to infinity a n cos n pi x by l plus bn sin n pi x by l. Okay, so where you have to calculate an using some formula, bn using some formula. So these were the things which you have done in the previous semesters. Okay, so when you are asked to expand a function as a Fourier series, you have to write the expansion like this, and you have to calculate these coefficients an, bn, a naught, etc. Okay, that is what you have to do that. Similarly, Fourier integral also has an integral representation. Your function f of x will be written as an integral containing some ans and bns. Okay, so when you are asked to expand a function as Fourier integral, first you have to write this representation just like this one, and then you have to find the value of an and bn. So that is what you are going to do in this section. Okay, so when you are asked to expand a function as a Fourier integral, you have to write an integral representation formula, and then in that integral representation formula there will be some coefficients which you have to find using some formula. Okay, so basically the Fourier integral formula is an extension of the Fourier series. Okay, you know that Fourier series were defined for periodic functions. Okay, so basically it was defined for periodic functions. So but all our functions need not be periodic. Okay, so when the functions which we deal in real life need not be periodic always. So in those cases, when your period is, we will assume that the period of the function is actually infinity. So when the period is assumed to be infinity, your Fourier series will actually be transformed to Fourier integral. Okay, so the basic representation of Fourier integral is obtained from the limiting case of Fourier series. Okay, so it is not required for you, the derivation of that is not required for you. What is required for you is just you need to know the formula only. Okay, so you need to study the formula and then the corresponding coefficients. Basically it is all derived from the Fourier series where the period of the function is taken as infinity, or else you will say that the function is non-periodic. Okay, so you are actually applying the limiting case to the Fourier series representation to obtain the Fourier integral. That is why it is called Fourier integral. Okay, so this is the theory part. It is not required for you, this is just for understanding. I am telling you. So as I told you, here the period is considered to be the entire linear line. Okay, and so you can see that there will be some functions satisfying some record conditions, just like there were Dirichlet's condition Fourier series. So they can ask you state the conditions for existence of Fourier integral. Some statements would be there. Okay, just like in the Fourier series, there were some conditions where your function need to be piecewise continuous, there should have a finite number of maxima, minima, etc. So there were some conditions which you had studied in the Fourier series. So those conditions will be like there in Fourier integral also. Okay, it's just for your examination purpose. They can ask you that conditions. I will also state that conditions. But the main question here is you will be asked to represent a function as a Fourier integral. Okay, so for that here it will involve finding some an integral representation which contains some coefficients like an, bn, a naught, etc. By using some sort of formula, you will have to evaluate those variables. Okay, so basically Fourier integrals is just like finding Fourier series problem. Okay, so you have to study one integral formula, and that integral formula would contain some coefficients like ans and bns. You will also have to find that an and bn. That is the idea here. Okay, it's a very simple thing. If you know Fourier series, it's just a similar approach here. Okay, so let us now write down the formula here. The derivation of the formula is not required for you. You only need to write down statement. Okay, so this is the statement for existence. Suppose I am taking a function f of x which is piecewise continuous. Okay, so these conditions are just for your knowledge only. It is not the derivation or the existence condition is not required for you. You just need to, sometimes they can ask you to state the conditions where the Fourier integral exists. Maybe for 3 markers they can ask you. Okay, so these are the conditions in which the Fourier integrals are existing. What are the conditions? First of all, the function should be piecewise continuous. Okay, I hope you understand what you mean by continuous function. A continuous function is a function which has no breaks. Piecewise continuous means there can be some finite discontinuities. Okay, so it will be like this. Okay, and in every finite interval and has a right hand derivative and left hand derivative at every point. Okay, so you know that the discontinuity, so it's just for information only. So the basic idea is that always the discontinuities are of order 1, first kind. Okay, that's not required for you, just I'm telling you the meaning of these things. It is not required for you. What is required is basically the formula. Okay, so these are just the existence conditions of Fourier integral only. Okay, so these are the conditions. First of all, it should be piecewise continuous, and it should have a right hand derivative and also a left hand derivative at every point, and also the function should be integrable. Only then you can find the integral. So that's called absolutely integrable. The meaning of these terms is not required for you. This is just an engineering course only. So these are very fine points which is dealt with in advanced mathematics course. It is not required for you. Just understand that the function should be you should be able to integrate the function. Okay, so with these conditions the function can be represented as a Fourier integral. Like I'll write the integral here. So your f of x, just like your Fourier series, it can be written as integral 0 to infinity an, okay, some an into cos nx, okay, cos nx plus bn into sine. So similar to that, if you can see this similar to that, right? So instead of n they have used a symbol omega, but it's the same thing here. Okay, so an into cos nx plus bn into sine nx dx. Okay, so if you look at this representation, you can see that similar to our Fourier series representation. In our Fourier series, it was like sigma n is equal to 1 to infinity an cos nx plus bn sin nx there in the case of Fourier series. So similarly, I am extending this Fourier integral is an extension of the Fourier series. So that is why instead of summation, you will have an integral here, integral 0 to infinity an cos nx plus bn sin nx dx, and then you have to find the formula for an and bn. Okay, so this is the representation roughly. Okay, I will give you the correct representation, but roughly this is the representation. So when you are being asked to represent a function as a Fourier integral, you have to, first of all, you have to write this representation, then you have to find the value of an's and bn's, and then you have to substitute it back in the integral. So that is the idea here. So this is roughly the representation. Okay, now let us look at the correct representation. Okay, so your f of x can be written as, so instead of x I am using the symbol omega here. So your f of x can be written as some a omega into cos omega x plus b omega into sin omega x d omega, where your a omega is, okay, it's basically 1 by pi integral minus infinity to infinity f of x into cos omega x dx, and also your b omega is equal to 1 by pi integral minus infinity to infinity f of x into sin omega x dx. Okay, so some words here. So this is just like a Fourier series itself. In the Fourier series, you know that the your an was simply whatever it is 1 by L or 1 by pi minus L to L, okay, f of x into the coefficient of that thing. Coefficient of that is f of x into cos nx dx. If you are taking L as pi, it will be simply be 1 by pi into integral minus pi to pi or 0 to 2 pi f of x into cos nx dx. So the same thing is being applied here itself. Here the period is actually the infinity, so that is why it is known as minus infinity to infinity f of x into the coefficient of a omega is cos omega x. It will be coming here. So same thing here. So it is f of x into cos omega x dx. Similarly, it is f of x into sin omega x dx for b omega. Okay, and why am I calling it as a omega? Because when I calculate this integral, you can see that this integral contains the variable x. So when you do the final computation, when you compute the integral, if you substitute the limits for x and all, what will happen? You will be getting a answer in terms of omega only, because omega here is a constant. Okay, so the answer will contain omega. That is why it is written as a omega. So here also, when you what happens is that when you just compute everything with respect to this, and when you this is integral with respect to x, so when you compute everything and then substitute these limits, what will happen is that your answer would contain this omega. That is why it is called b omega. Okay, so remember this a omega and b omega would contain this x here. Okay, and similarly, if you look at when you substitute this a omega b omega into this formula, this integral is in terms of d omega. This integral is in terms of omega. Why is it so? Because your final answer should be in terms of x. So if you write in dx, your final answer would only be in terms of omega. So that is why this integral is written as d omega. So just think here, your a omega contains omega only, your b omega contains omega only, and the integral is with respect to this omega. So when you integrate, everything will be in terms of this omega, and you will be substituting the value 0 and infinity for your omega, which means your final answer would contain x. Okay, so that is how this f of x will be equal to this quantity. Okay, so don't confuse with this d omega and dx. So be careful. Your a omega would contain dx, d omega dx, and your f of x would contain d omega. So be careful with the variable of integration. Okay, so if you just think logically, you will understand why it is so called a omega, because the integral contains dx, and then in the case of that, your omega would be the variable coming out, so it will be in terms of omega. That's why it's called a omega. So similarly, b omega also contains that property. When you substitute it back in the integral, the final answer should be a variable in terms of x. Okay, that is why in that case it is written as d omega. So please be careful of these fine points here. Okay, so I'll just write these formulas again for you. So these are the final formulas. F of x is equal to integral 0 to, so this is the Fourier integral formula for you. Okay, so now the questions will be there. You will be given an f of x, you will be asked to find the Fourier integral representation. The question is very straightforward. Just substitute the function into this one, find the values of a omega, find the values of b omega, and substitute in the integral, write f of x as an integral. So that is the problem which will be coming from this section. Okay, and one more fine thing is there. So this integral representation, just like your Fourier series, will be equal to f of x at all points of continuity. Okay, just like your Fourier series, the same concepts are coming here. At all points of continuity, both these things will be the same. Okay, but at the points of discontinuity, okay, suppose your point x0 is a discontinuous point, this integral would be equal to the average of your right hand limit plus left hand limit. So it will be half of, so if it is a discontinuous point, there will be left hand limit will be there, right hand limit will be there, so it will be half of RHL plus LHL. Okay, just like your Fourier series. Okay, so at discontinuous points, this integral representation would be equal to half of the left hand limit at that point plus right hand limit at that point. Okay, so this is the same concept which is there in Fourier series also. So this idea will be helpful when you will be asked to show some integral is equal to. So the questions which can come from this section is, you will be given a function, you will be asked to find the integral representation, and another question which can come is that they will give you an integral representation, so we will ask you to prove that this integral representation is equal to this function. Okay, so in that cases, this idea will help you. This integral representation would be equal to f of x at all points of continuity, and at the points of discontinuity, the integral representation would be equal to half of average of the right hand and left hand limits. Okay, we will do that such problems and you will understand it better, but that is some fine points which will be which is remarkable in this case. Okay, so this is it here. So as I told you, f of x at a point where f of x is discontinuous, the value of the Fourier integral equals the average of the left and right hand limits of f of x at that point. Okay, so at all points of discontinuity, the integral representation would be equal to f of x. Okay, now let us do a problem now. Okay, so this is our Fourier integral. We have studied Fourier integral, we know the formulas and everything. Let us now try to do a problem. Let us try to expand a function as a Fourier integral. Okay, so let us find the Fourier integral representation of the function f of x is equal to 1, where mod x is less than 1, and 0 if mod x is greater than 1. Okay, so it's a very simple thing. So your f of x is equal to 1, where minus 1 less than x less than 1 and 0 elsewhere. Okay, so what is the integral representation? As we know, the formula is your f of x is equal to integral 0 to infinity a omega cos omega x plus b omega sin omega x, b omega sin omega x, d omega. Don't forget d omega here. Okay, so always write the formulas, because always the formula will carry 1 or 2 marks. So that is there, and we have to find a omega. What is the value of a omega? A omega is simply 1 by pi integral minus infinity to infinity f of x into cos omega x dx. So in this case, what is it? It is simply 1 by pi integral minus infinity to infinity f of x into cos omega x dx, but my f of x is there only for minus 1 to 1, rest derivative is 0, so this will be reduced to 1 by pi into minus 1 to 1 cos omega x dx. What is it? Value is simply 1 by pi into sin omega x in the limits, or you can write that it is basically sin omega x in the limits minus 1 to 1, because the integral of cos omega is sin omega x by omega. Okay, so cos sin omega x by omega in the limits minus 1 to 1, so that is equal to 1 by pi into sin omega by omega minus again minus sin omega, which is again plus sin omega by omega, because it's a lower limit there. So it is simply be 2 sin omega by omega pi. Okay, so I hope it is correct. Please correct me if I am wrong. Or else you can also do it another way. You know that this function is an even function, so it will simply be 2 by pi into integral 0 to 1 cos omega x dx. So there also, if you integrate it, what is it? It will be simply be 2 by pi into sine omega x in the limits 0 to 1. So it is simply 2 sine omega by pi minus sine 0. So you will be getting this as 2 sine omega by omega pi. Okay, so that is your an. Okay, so what is your bn? So if you have understood this odd or even function, that concept, if you know that your value of bn is b omega is actually integral 1 by pi into minus infinity to infinity f of x into sine omega x dx. Okay, so it will become so I have written the I omega here. So b omega will be similarly it will be simply be 1 by pi into integral minus infinity to infinity f of x into sine omega x dx. Okay, so your f of x is only from minus 1 to 1, so it will be simply be minus 1 by pi into minus 1 to 1 sine omega x dx, and this is sine is an odd function, so it will become 0 there, or else you can also compute it directly, then also you will be getting that 0. So your b omega was 0. Okay, so now you have got your a omega and also b omega. So what is the final integral representation? The integral representation was f of x is equal to integral 0 to infinity a omega cos omega x plus b omega sine omega x d omega. Okay, make sure of this brackets, and so your b omega is 0, so it will simply become integral 0 to infinity a omega is 2 by pi omega. So 2 by pi into sine omega cos omega x by omega d omega. Don't take this omega outside. This is not a constant in this integral. Only these are constants. So it is simply 2 by pi. Okay, sine omega cos omega x by omega d omega. So this is the integral representation of f of x. Okay, I hope it is clear. Okay, so now let us look at one more fine points here. So I hope it is clear how to find the Fourier integral representation. Okay, now suppose now if you look at this quantity, now if I am just looking at this integral, now this integral will be equal to f of x at all points of continuity. This integral would be the same. So this is the answer of this question. The question is over now, but I am just trying to discuss some more aspects here. Okay, suppose if you are looking at your RHS, your integral. Okay, so what is it? It is simply 2 by pi into integral 0 to infinity cos omega x into sine omega by omega. So okay, there is also one d omega here. Okay, so that please put that also d omega. Okay, now this will actually be equal to f of x at all points of continuity. Okay, look at f of x. Where are f of x continuous? F of x is continuous at all points, where at all points from minus 1 to 1, and also for all points which are greater than 1. But at the point 1, this function is not continuous. Why? If you just draw this function, you can see that. Okay, so this is your f of x. At all points from minus 1 to 1, the value is 1. Rest your value is 0. So there is a discontinuity at the points at the point 1 and also minus 1. Also there is a point of discontinuity. Okay, so the function is discontinuous at the point 1 and also minus 1. Okay, so because there is a break there. Okay, so at all points except this 1 and minus 1, the function, this integral would be equal to the value of f of x. Okay, so I can write this as this is equal to 1 for mod x less than 1 and 0 for mod x greater than 1. Okay, what happens when mod x is equal to 1, or that means what happens when your x is equal to 1 or minus 1? What will be the case? In that case, this integral representation would be equal to half of LHL plus RHL. Okay, now what is LHL of this? At the point x is equal to 1, what is the LHL? Your LHL is left hand limit is 1, your RHL is equal to 0. So at the point x is equal to 1, you will have the integral would be equal to half of 1 plus 0 by 2, which is half of 1 plus 0, which is equal to 1 by 2. So at x is equal to 1, the value will be equal to 1 by 2. And similarly at x is equal to minus 1, your LHL is, if you look at the left hand limit, it is 0. If you look at the right hand limit, it is 1. So at that point, the value would be equal to half of 0 plus 1, which is again 1 by 2. So at minus 1 also, you will be getting it as 1 by 2. So this integral can be written as this also. Okay, so they can ask you, show that, so instead of directly asking you to find the Fourier integral representation, they can ask you, show that 2 by pi into cos omega x sin omega d omega by omega is equal to this. They can ask you like that also. Okay, or I can just modify it again. I'll just modify this question. Can you show that integral 0 to infinity cos omega x sin omega by omega d omega is equal to, I'm just taking 2 by pi out in the RHS, it will become pi by 2 where mod x is less than 1, 0 if mod x is greater than 1, and 1 by 2 if mod x is equal to 1. So they can ask you like that also. So the question can be rephrased like this also. Okay, so you will be asked to show a particular integral is equal to this one. Okay, so how will you proceed in that case? In that case also you can see that this is actually a Fourier integral representation only. So how will you take, so you have to find an f of x. So they have not given you f of x here, they have just given you the representation. So what will you do? You will take the RHS as your f of x. I'll just take that f of x is equal to pi by 2 where mod x is less than 1, 0 if mod x is greater than 1 by 2 if mod x is equal to 1, and then I will try to find the Fourier integral representation. Okay, so those type of questions also we will do, but all the questions is having the same idea. All the question will reduce to just finding the Fourier integral representation. So the same question could be rephrased in many ways in this module. Okay, but essentially everything is just the same. Okay, so this was just for information. When you do the problems, you will understand it better. So I hope it is clear how to find the Fourier integral representation. Okay, so as I told you, this is the case here. Okay, so straight away they can ask you this question itself. They can ask you to show this also. Okay, so this also can be done. Okay, so I hope it is clear now. Okay, so so everything is there. So moving forward. Okay, so here they have not given you what is x is less than 0. So when x is less than 0, it is assumed to be 0 here. But you will understand it better when you study cosine integral. I'll discuss this problem is actually a problem of cosine integral only. I'll discuss it there. But still assume that a function is 0 where x is less than 0. You can take it like that. So you can take your f of x as this. Okay, and try to prove this quantity by just doing the computations here. Okay, so if you given a question like this, show that cos omega x sin omega by d omega is equal to pi by 2 if 0 less than or equal to x less than 1, pi by 4 if x is equal to 1, 0 if x greater than 1, etc. And if you are asked to show it like that, so you can take your f of x as this, and then you have to can find the Fourier integral of that function, you will obtain this result. So this question can also be asked in the reverse process also. So two type of questions we have discussed in the same question. Okay, two types of questions can be addressed in the same manner in this question. Okay, sometimes they will give you f of x, sometimes you have to take f of x as your RHS. Okay, to show it like that. Okay, so similarly, let us do, so here are some Fourier integral problems here. So these are some questions like that. So let us take one problem here. Suppose we are being asked to do this problem here. Okay, so suppose you are being asked to find out, show that using Fourier integral representation, you have to prove this quantity. Okay, so let's try to do this. So how do you can see that these are all Fourier integral representations are there. Okay, so let me take this question. So in order to use the Fourier integral representation, I need a f of x. They have not given you f of x. So I'll assume that this is my f of x. So I'll take this is equal to my f of x. Okay, in some textbooks they will also take f of x in other format, but this is the easiest way. Just take it like this. Okay, in some textbooks they will just avoid this constants, pi, etc. But that is not much significant. Just take your RHS as your f of x always. Just take RHS as your f of x. Okay, now let us try to find the Fourier integral representation. Okay, so what will I do? So my Fourier integral representation is, as you know, it is actually f of x is equal to integral 0 to infinity a omega cos omega x plus b omega sin omega x d omega. Okay, this is for integral representation. We need to find a omega. Okay, so what is a omega? A omega, as you know, it is 1 by pi integral minus infinity infinity f of x into cos omega x dx. So in this case, you know that when x is less than 0, your values are 0. When x is equal to 0, value is pi by 2. But a single point does not matter here, because your integral will become like 1 by pi. It will be integral minus infinity to 0 plus integral 0 to 0 plus integral 0 to infinity. So you can split the function like that. In this case, minus infinity to 0, your f of x is 0, so it will be 0 here. In the case when integral is from 0 to 0, whatever may be the f of x, still the integral will be 0, because your left hand limit, your upper limit and lower limit is 0. So only this case would remain. So your a omega will reduce to simply 1 by pi into integral 0 to omega. F of x is actually pi e raised to minus x into cos omega x dx. So if you find this, you will get your a omega. Okay, so I hope that is clear. So similarly, you can find b omega also. When you have to find b omega, what you have to find? Your b omega will be again be equal to 1 by pi into integral 0 to infinity. Sorry, it is not omega, 0 to infinity pi e raised to minus x into sin omega x dx. Okay, don't confuse it with d omega dx there. Okay, so when you compute both these things, you will be getting the integral representation. We will do that also now. Okay, so please remember this. What is it? Okay, so let us try to find it out again. So your A omega was 1 by pi integral 0 to infinity. What was it? It was pi e raised to minus x. So please try to do with me. Okay, pi e raised to minus x into cos omega x dx. So for cos omega x dx. So that is it. Your pi would get cancelled out. So you know what is the formula for e raised to ax into cos bx. What is it? It is simply dx. It is simply e raised to ax by a square plus b square into a cos bx plus b sin bx. Okay, similarly there was a formula for e raised to x into sin bx also. What is it? It is simply e raised to x by a square plus b square into a sin bx minus b cos bx. Okay, so these are the formulas. You can use these formulas here. So it will be simply be e raised to x. So it is e raised to minus x by 1 plus omega square, right? Your a is actually minus 1, your omega, b is actually omega, so it is 1 plus omega square into, what is it here? So it is a cos bx, so it is actually minus cos omega x minus b sin bx. So your b here is actually omega only, plus minus, so a cos bx, a is actually minus 1, your cos omega is there, plus b is actually omega, so it is omega sin omega x. Okay, in the limits 0 to infinity. So when you apply infinity here, e raised to minus infinity, the entire thing will become 0. There's nothing to do there. When you apply 0 there, you will be getting it as 1 by 1 plus omega square. It is lower limit, so minus 1 by 1 plus omega square. When you put x as 0 here, you will be getting as minus cos omega, minus cos into 0, which is again 1 there. So you will be getting 1 into minus 1 there. Okay, plus when you put x as 0 here, this will become 0. So your answer is actually 1 by 1 plus omega square. So this is your a omega. So on a similar note, what is your b omega? Your b omega is again, when you substitute, it will be simply integral 0 to infinity e raised to minus x into sin omega x dx. You have to be very careful with integration here. Only if you know integration well you can do these problems, but these are all very straightforward integration. We have done so much of these things in Fourier series in your last semester, so just carry on those ideas there. Okay, nothing new is there, everything you know it now. Okay, so please try to do more problems here. So when you do it here, we will get it as e raised to minus x by 1 plus omega square. Here it will be a sin a sin bx, or a is minus 1, so minus 1 sin omega x minus b is actually omega here, omega cos omega x. Okay, minus omega cos omega x here. Okay, so when you put your integral from 0 to infinity, when you put infinity, you will be getting e raised to infinity, it will become 0 there. So when you put 0, it will be 1 by 1 plus omega square. Okay, now minus this there. Okay, and when you substitute it here also, you will be getting it as your when you substitute it here, what will happen is that this will become 0. This is actually 1 there, so it is minus omega, so it is actually plus 1, so it is again 1 plus 1 by omega. So finally you have got your a omega and b omega, so your final answer will be simply b equal to so it is, so have I made a mistake here somewhere? So okay, no, this omega is there, right? Omega would be there, right? So when you put your x as 0, you will be getting it as plus omega would be there, so plus omega would be there. Okay, so that's clear. Okay, so when you write the final answer, it will be simply be final representation would simply be equal to integral 0 to infinity a omega cos omega x plus b omega sin omega x d omega. Okay, so your a omega is 1 by 1 plus omega square, so it will be cos omega x plus omega into sin omega x by 1 plus omega square d omega. So that is your representation. Was this the representation that was asked? Yes. So this was the representation to us, just 1 by 1 plus omega square into cos omega x plus omega sin omega x dx. So that is how you do with these problems. Okay, so similarly you can try the other problems also. Take your RHS as your f of x and then start representation. Okay, so I hope that is also clear to you. Okay, so the problems can become as straightforward. They can ask you for finding the Fourier integral, or they can give you a question like this and ask you to prove it. Okay, so these type of problems are very straightforward, so please try to do more and more problems. Okay, so here also we can make some tweaks there, but I'll tell you more about these tweaks when we will discuss Fourier sine integrals and cosine integrals here. Okay, so that is there. So this is our presentation and everything is there. So here I have taken it from a textbook where they have taken a f of x as a modified form of your RHS, but it is not required for you. just take your RHS, whatever it is, as RHS, take it as f of x. Your RHS here was 0, pi by 2 x. They have just avoided this pi there and written the f of x here. It is not required for you. Just take whatever is given to you as your RHS. Okay, whatever is given to you should be taken as your RHS. Don't try to tweak it there, because you can easily forget those scalars. Okay, so be careful there also. Okay, so let us move forward now. So as I told you, your Fourier integral representation was, let me write once again, f of x is equal to integral 0 to infinity a omega cos omega x dx, sorry, not dx, cos omega x plus b omega, okay, one second, okay, plus it is actually b omega into sine omega x d omega, okay, where your a omega was 1 by pi integral minus infinity to infinity f of x into cos omega x dx here, okay, and your b omega was 1 by pi into integral minus infinity to infinity f of x into sine omega x dx. Okay. Now this problem can be greatly simplified if you have some special cases. Suppose your function f of x is even. Okay. You are finding a function f of x is even. What will happen? When f of x is even, this quantity will be even, right? And this quantity will be odd, just like your Fourier sine series. Just think of your Fourier sine series and cosine series. When your f of x is even, f of x into cos omega x would be even, and f of x into sine omega x would be odd. So when you integrate from minus infinity to infinity f of x into sine omega x, this will become 0. And this will become 2 by pi integral 0 to infinity f of x into cos omega x dx. Okay, so when your function f of x is even, your integral representation would reduce to, your f of x will simply be integral 0 to infinity a omega cos omega x d omega only, because your b omega is 0, where your a omega is simply 2 by pi into integral 0 to infinity f of x into cos omega x dx. Okay, so this is applicable only when your function is actually even. Okay, when the function is even, this will happen. Okay, so this integral, which contains only cosine terms, is called Fourier cosine integral. Okay, so if you are asking you to find a Fourier cosine integral representation of some f of x, so in that case probably they will give only from x is equal to from x is equal to 0 only they will give you f of x. Here they will give the f of x function f of x only from the point 0. Okay, they will tell you f of x is equal to maybe e raised to minus x when x is greater or equal to 0. So the question will be from here. Okay, so it is assumed that the function is even there. Only then you can find the Fourier cosine integral representation. Okay, so even if it is x is less than 0 also, this function is e raised to minus x only. So don't be confused, they won't give you like that, but I'm just telling you the basic assumption here is that the function f of x is even. Okay, but you will not have to check whether the function f of x is even, because always the function will only be given to you from x is greater or equal to 0 in these cases. Okay, so this is just for information, this is not required for you, but remember, the Fourier cosine integral is actually a special case of the Fourier integral when your f of x was even. Okay, so there is nothing new to study here. Only thing is that this b omega would become 0 there. Okay, so rest everything is just the same. So analogously, when your f of x is odd, what will happen? When your f of x is odd, this quantity will become odd, this quantity will become even, and your a omega will become 0, and only b omega will be there, and the f of x will be like integral 0 to infinity b omega sine omega x dx, where your b omega is 2 by pi into integral 0 to infinity. So in that case, you will only have sine terms. It is called the Fourier sine integral. Okay, so both the Fourier cosine integrals and sine integrals are basically special cases of your Fourier integrals when your f of x is even or odd. Okay, so for your case, in your questions, basically they will only ask you to expand the function as a Fourier cosine integral or expand the function as a Fourier sine integral. Okay, so these type of ideas can come there also. Okay, I hope though. So there is nothing new to learn here. If you know Fourier integral, you will also know Fourier sine integral and cosine integral. Okay, so this is the representation. So they can directly ask you to find the Fourier cosine integral. Just take the value, plug it in the formula, and find the answer. Okay, so let's do one problem here. Let us find the Fourier cosine integral of e raised to minus kx. So what will you do? Just like your Fourier integral, you know the Fourier cosine integral representation is your f of x is equal to integral 0 to infinity a omega into cos omega x dx. Always write the form cos omega x d omega. Don't make the mistake. Okay, always write the formula first of all, and your a omega is basically 2 by pi integral 0 to infinity f of x into cos omega x dx here. So it is actually 2 by pi into integral 0 to infinity e raised to minus kx into cos omega x dx. Just like the earlier formula, it will be simply be 2 by pi into it is actually e raised to minus kx by k square plus omega square, right, into you will be getting minus k cos omega x plus omega sin omega x in the limits 0 to infinity. So when you put infinity, this will be 0 because your k is greater than 0. They have given you the k is greater than 0, so this will become 0. And when you use 0, it will have minus 2 by pi and 1 by k square plus omega square, minus because it's a lower limit here, minus 2 by pi and 1 by k square plus omega square into, when you put omega x as 0 here, will be getting it as minus k there, and your sin omega x will become 0. So it is actually 2k by pi into k square plus omega square. Okay, so in that case, this is your a omega. So our final answer would be 2k by pi, you can take it outside, integral 0 to infinity cos omega x by k square plus omega square d omega. Okay, so that is how you write the Fourier integral representation. Okay, so 2k by pi, this is it. Okay, so now I'll just give you an idea. So sometimes you will be asked to show that this is equal to 2k by this is equal to your e raised to minus kx, where x is greater than 0. Okay, so they will ask you a question like this. So when you see that your function is only consisting of only x greater than 0, always remember this is either a Fourier cosine integral or sine integral. Always remember that this is either a Fourier cosine integral or a sine integral, because if it is given for the entire real line, it will be basically Fourier integral. When it is only x greater than 0 or from x is equal to 0 onwards, it will be either cosine integral or sine integral. Okay, and if it contains only cos omega x, it is a cosine integral. If it contains only sin omega x, it is a sine integral. If it contains both, it will definitely be cosine and it will definitely be the Fourier integral. But these are just some simple techniques to do the problems here. So if your integral representation contains only cos omega x, remember it is the cosine integral. If your integral representation consists of only sine omega x, it is the sine integral. That is one idea. If it contains both cos omega x and sine omega x, you will have to expand the function as a Fourier integral. Okay, so this is some idea which you can use to simplify some problems. Even if you do the problem in terms of Fourier integral, also the answer would be the same here, because here f of x is actually 0 there, but it's no issue there. So but these are some basic ideas you have to assume here. Okay, so let us look at the previous problems here. So the previous set of problems, there was, you will just observe these problems here. Okay, so in the first case, it was a Fourier integral because it had cos x omega and sin x omega. Okay, in the second case, if you look at there, it is only from 0 to, it is a function which is from starting from 0 to only, not less than 0 is not there, so it's basically a cosine integral or a sine integral. But you know that it is actually sin x omega is coming there, so you have to expand this function as a Fourier sine integral. We'll come to that later, but I'm just telling you. And similarly, if you look at this one also, it contains only sin x omega, cos x omega is not there. Okay, if it was a Fourier integral, it will contain cos x omega and also sin x omega, because Fourier integral is written as a omega cos x omega plus b omega sin x omega. So both should be there, but here it contains only sin x omega. Okay, don't look at this one. You should have sin x omega and cos x omega also. So here only sin x omega is there. That means you have to expand this as a Fourier sine integral. And if you look at this quantity, you can see that actually there is a Fourier cosine integral, because only cos x omega is there. Similarly, you can think of these things also. It is again sine integral, cosine integral and everything like that. Okay, so I hope this is clear. And if you look at this function here, this one, if you want, you can do it as a Fourier integral also, because they have given you the value for entire real line here. So if it is like that also, you can, instead of cosine integral, you can directly go for just try for directly Fourier integral also, but still you will be getting the same answer, because here if you look at the interval, it is given, the entire real line is given. For cosine integral, only from 0 to infinity is needed here. If you want, you can do that also, but if you do it, expand this as a Fourier integral or a cosine integral also, the answer would be just the same only. Okay, this I'm just telling you. So in this case, try to expand as a Fourier integral because they have given you the entire real line. If they have not given you the entire real line, you can actually simplify the problem. That is why I'm just telling you how to simplify this problem. If the term contains only sin x omega, expand as a Fourier sine integral. If it contains only cos x omega, expand as a Fourier cosine integral. Okay, so this is just for simplification purpose only. Okay, so that's your Fourier sine integral, cosine integral, and some more problems are given to you like this. You can try to do these problems here. Please try these problems. Just write down the formula, plug in the values, you can do it, everything. It's a very simple thing. So similarly, Fourier sine integral problems also is there. As I told you, in the function sort, your integral would be simplified again like this. This is your Fourier sine integral. Okay, so let's do one problem also here. So if you want to show that, express the function as a Fourier sine integral and show it like this. Let us try to do this one. So what is a Fourier sine integral? If you know, it is actually f of x is equal to integral 0 to infinity b omega sine omega x d omega, where your b omega is basically 2 by pi integral 0 to infinity f of x into sine omega x dx, right? This is your b omega. Okay, now your f of x is, what is your f of x? F of x is actually equal to sine x. Okay, so it is from 0 to pi only is there, sine x into sine omega x dx. How will you do this problem? You have to use the 2 sin A sin B principle here. So 2 sin A sin B is cos A minus B minus cos A plus B. So it is actually 1 by pi into, you have done these problems in your Fourier series cases, so it's where I am going forward. It's a very simple thing. 2 sin A sin B is, what is 2 sin A sin B? It is cos A minus B minus cos A plus B, right? So here it is actually cos x minus omega x, so it is 1 minus omega x minus cos 1 plus omega x. Okay, cos 1 minus omega x minus cos 1 plus omega x dx. Okay, now integrate it. What will you get? So when you integrate, so what will you be getting here? Okay, so when you integrate this, actually it will become 1 by pi into integral of cos is sine 1 minus omega x by 1 minus omega minus again sine 1 plus omega x by 1 plus omega in the limits 0 to pi. Okay, so it is actually sine 1 minus omega x by 1 minus omega plus minus sine 1 plus omega x by 1 plus omega there in the limits integral 0 to pi. Okay, so when you put pi, it will be 0. So again, when you put x is equal to when x is equal to, so when you put one case here. Okay, okay, so it is cos sine 1 minus omega into x minus cos 1 plus omega into x there. Okay, so okay, so when you integrate it, you can see these things here. So it is sine omega minus 1, sine omega minus 1. So this is there. When you put the value of pi there, you will be getting a sine omega minus 1 pi, and then sine omega minus 1 pi will be there. Okay, and this quantity here, so you can see these quantities. When you substitute it there, you will be getting this. What is sine omega 1 minus 1 pi? So here remember, sine omega minus 1 into pi, don't put it as 0 because you don't know the value of omega. If it is an integer, it will be 0 here, but omega is a constant, we don't know what is it. So don't write sine omega minus 1 is equal to pi is equal to 0 because omega is not an integer. But what is the value of sine omega minus 1 pi? What is the value of sine omega 1 minus 1 to pi? It is actually, if you want, you can write the sine omega pi minus pi there. So if you reverse the form of sine A minus B, it is actually sine omega pi cos pi. Okay, again minus cos omega pi sine pi. So this will be actually 0. Cos pi is minus 1, so it will simply become sine omega pi minus sine pi omega, because cos pi is minus 1, so it will become minus sine pi omega. Or you can use that or you can use that product rule also there. So this sine omega minus 1 pi is actually minus sine pi omega, and similarly sine omega plus 1 pi is actually again, it's the same concept will come there. Sine omega pi cos pi, again cos omega pi sine pi minus omega is sine pi is 0, cos pi is minus 1, so it will become minus sine pi omega, so it will be getting it as plus sine pi. Okay, and similarly you will have omega minus 1, omega plus 1 here. So omega is not equal to an integer value, so don't make the mistake of writing sine omega minus pi as 0. So you'll be getting this one, and when you simplify it, you will get this as simply minus 2 sine pi omega by omega square minus 1. This is the answer. Okay, so this is your what do you say, b omega. So your final answer would be simply be f of x is equal to b omega into this, or you can say that this one is equal to pi by 2 into f of x, and this is the final answer. Okay, so I hope that is also is clear, straightforward calculation here. Okay, so that's also there. So I hope this was clear to you. Okay, so that is Fourier sine integral, and some more problems are given to you here also. Please try to do these forms also. So these are the questions will be coming from this section. Only basic questions like expand as a Fourier integral, sine integral, cosine integral, and some identities to prove will be asked from the section. In some other guidebooks and all, they have given you very tough questions. It is not required for the exam. Just study these things only. Okay, thank you.